Okay, so the first thing I want to go over on this is what's meant by even and odd functions. If you had some pre-calc, you would have learned this kind of an idea. And the idea is there's the functions, first thing I want to show you is they have a certain kind of symmetry to them. So the idea is an even function, and a lot of times students read this and don't understand what that says. This is a good note to write to yourself. It basically just says this: if you have an opposite x, then you have the same y. Now, I talked about that in the last section, and that told you what kind of symmetry that is. So as an example, that would mean, like, say for instance you have a point 1, 2 on the graph, then you would also have to have negative 1, 2. So what it means is if you have the same, if you have an opposite x, then you have the same y, right? So what that is an even function is going to kind of look like this example right here. How is this one symmetric? Just by looking at it. This is symmetric about y, isn't it? Okay, so even functions are going to be symmetric about y, basically. Okay, so down at the bottom, if it's even, then it's symmetric about the y-axis. Okay, so you want to know what this statement says. That really, in words, just says opposite x gives you back the same function value, like that. And a function's odd if this holds. Okay, so what this means is when you see that f of negative x, that means if you have an opposite x, well, what happens to the function value? There's a negative f of x, so that means that's going to give you an opposite y. Okay, so an example would be like if you have a point, like this would be an odd function. I'll just say you have a point, and I'm just making this up. So I'm just saying, okay, that's the point 2, 7. Well, you would also have to have a point negative 2, negative 7, like that. And then how is that symmetric if you have opposite x, opposite y, like we learned in the last section? What was that? Origin. Okay, so that's origin symmetry. So if your function's odd, then you're symmetric about the origin. Okay, students generally can see how the graphs are symmetric. That's not a big deal, but you want to understand how the points work, because we're going to do some little, kind of like little proofs of whether a function's odd or even, and you have to understand that, I think, well to do that. Okay, so that's what I'm trying to do on this page, to kind of get you the definition going here. So this statement right here says, if the point 3, 4 is on the graph, then it's an even function. Well, if it's an even function, that just means that you have the same x, but you have opposite y. Okay? Now, hold on. That's not right. It goes like this. If you ever forget this, you know symmetric about the y would look like this. So an example, like if you had a point 2, 3, this would be a point negative 2, 3. So if you have opposite x, then you'd have same y. So what would 3, 4 become if you had opposite x, same y? Negative 3, 4. Okay, good. Okay. And so you don't have to memorize that. You understand visually what it means for something to be symmetric about y. You just make a little example like that, like I did there, and that'll help you understand that, see. Okay? So in general, if you have a point x, y, and you have an even function, that means, again, the same thing as the last problem. That would just mean if you have an opposite x, you have the same y. So if your function's even, that's the structure. Same y, opposite x. Okay? Right? And then if it's odd, what's the deal with odd? Both are opposite, right? So if it's an odd function, both things are opposite, so this would become 2, negative 4. Okay? All right, and what happens on this, you don't have to write this graph on here, but if you had a point 2, negative 4, or 2, 4, well, that's not what I meant to do. If you had a point 2, negative 4, and then you have the point negative 2, 4, that's the way origin symmetry works. It's usually about the origin that it's symmetrical. So if you folded this over x, then folded it over y, those points would match. Okay, so that's how that would go. And the next problem, xy, if it's odd, what point would you have then? Both are opposite, so that's negative x, negative y. So that's what you got to get solid in your mind, is what the symmetries are and how those points transform. Okay, any question about that? Okay, all right. You can always refer to that, but you want to try to understand it And if you just understand how the symmetry looks, then you can figure out how those points transform. Okay? So here's the part of this section that sometimes students have a little trouble with. And on your first written assignment, which I put on Canvas, the thing that students a lot of times don't do is these problems very well. So you watch this carefully, because when I grade this, you have to show this in a certain way. So what you're going to do if I give you a function to show if it's odd, even, or neither is you always do this. You replace all the x's with negative x. Okay. Then what you do is if it's the same as the original, then that's going to be an even function. So what you're really doing is you're showing that opposite x gives same y. Okay, that's what it means for a function to be even. Okay, if it's opposite of the original, then the function's odd. So if you're going to show something's odd, you're going to show that an opposite x gives an opposite y. Okay, and then neither would just be you're going to end up with something that is not even or odd. Okay, that would just be if neither condition holds. So that's kind of the idea when you're showing algebraically whether something's even or odd. First thing is just replace all the x's with negative x, work it out, see if you end up with the same function or the opposite function or neither. That's what you got to do. Okay? Now watch this stuff on this stuff right here is not too bad because it's the symmetry. Symmetry is not hard for students, but it's the writing it out algebraically that has a problem. Okay, how is this one symmetric, by the way, just by looking at number 2? Symmetric about what? Y-axis, good. So if it's symmetric about y, is it odd, even, or neither? That's even, okay? So that's what we mean by an even function, okay? All right, the next one, how is number 3 symmetric? Or is it symmetric at all? I don't see any symmetry on that, so that's not symmetric about any axis or the origin, so that one would have to be a neither on that. Okay, so that's how that goes. Okay, so it's symmetric about y, then it's an even function. Okay. Okay, how is number 4 symmetric? Which one, if any? That's origin, isn't it? Yeah, this one's got origin symmetry. And again, if you have trouble seeing that, just pick a point. Like this is a point 1, 1. Notice that you also have a point -1, -1. So if both x and y are opposites everywhere on the function, then it's going to be symmetric about the origin, therefore it's an odd function. Okay? You with me there? Okay? Opposite x, opposite y. That's what origin symmetry means. Okay? Okay? How about the next one? Even, odd, or neither, just by looking. Even. Why is it even? Symmetric about what? About y. Okay, so this one is symmetric about y. Therefore, it's an even function. Okay, so that's how you do the symmetry. Okay, all right. So the next thing, this is what you want to watch carefully. This is the part that I have a hard time sometimes getting students to write this out correctly when you're doing a proof. Now you could graph this and tell whether it's even, odd, or neither pretty easily, but what you're going to do when you write this out, the first thing that we're going to do on this is let's just write down the original function, and I'll show you kind of the way I want you to write the steps on this. Okay, now over kind of on this second column, this is the way I want you to learn to write your proof. Okay, and you got to do it this way because a lot of times students write stuff on their paper and I'm not following that those students understand that. So the first thing we do is you want to write f of -x. And everywhere you see an x in that function, replace it with parentheses -x. So we'll have -9. And then we have -x squared like that. Okay, that's how you start your proof. Don't start it any other way. Always the same. Now, what happens to this part right here? If you square -x, what does it really become? just x squared, right? Okay, so your next step, you would write this as negative 9 x squared minus 6. So here's what you're always doing on this, okay? If this turns out to be the same as this, then it's even. Are they the same? Yes. So what you do is you write, and this is the conclusion. I want you to do that. I want you to go one more step and write f of x. That's what you're trying to do. So what you would say is since f of negative x equals f of x, then it's going to be an even function. See, that's what you're trying to show is that. And that's the definition of an even function. If x is negative, you just end up with the same thing. Does that make sense what I did? Right? Write your steps this way, okay? Always will kind of be the same idea, all right? All right, now this original and new function, you don't need to necessarily write this. I just want to get you writing the proof. So what we do on this, step 1 is always this way, f of negative x, and everywhere you see a x, change that to a negative x. Use like a parenthesis on that probably. So I'll write this as negative parenthesis, and then I put in the negative x, like that. Then in the bottom I have 7 times negative x squared, and then minus 3. Okay, so you want to do that. Okay, so now what I'm going to do is I'm just going to work this out. All right, what happens to this piece here? If you have a negative x to the third power, you're doing negative times negative times negative, so what do you end up with? End up with a negative, right. Okay, so this would end up giving you negative x cubed. You don't need those parentheses anymore, so that's what happens. And then down in the bottom, what happens to negative x squared? That becomes x squared because you have a negative times a negative, so it's a positive, so you get this. Okay, so now we're going to kind of clean this up, and then we'll see kind of what we have here. Okay, so the numerator now is positive x to the third. The denominator is 7x squared minus 3. Now, what I want you to do, you kind of do this part in your head. You just look at those two things, okay? If they're the same, if this is the same as this, it's even. If this is opposite of that, then it's odd. Otherwise, it's neither. So what do you think? Yeah, these are opposites. See, there's a negative there, okay? One thing that you want to make sure you understand, sometimes students don't see this correctly, but the way you make a fraction opposite is you just make either the numerator or the denominator negative, not both of them, okay? So that's opposite. So what you would write on this, on your conclusion, and you do that part in your head, you just say, well, that's equal to negative f of x. Okay, so I always want that conclusion written there, therefore it's an odd function. Okay, so when you do your homework on this, you want to make sure that you write these steps out this way, okay, because you're not going to get any credit if you don't, because otherwise I won't see that you understand the process. Okay, is everybody following me okay? Okay, always do these pretty much the same way, and they're not too hard. The algebra on these things is usually pretty simple, okay? Okay, let's try this one then. All right, so what we're going to say is f of negative x, and then what you want to do is just everywhere you see an x, just put in a negative x. And then we'll see kind of what we get when we do that then, all right? So the numerator is 3x. The denominator, now you can do this in your head. What happens if you do an absolute value of a negative, you just get a positive, right? So what this really becomes, and you don't have to write this step, but absolute value of negative x technically means the same thing as this. You can take the absolute value of negative 1 times absolute value of x. That's technically how you figure out that becomes 1, so you just get absolute value of x. But you need to take it back to that point like that, okay? So it gives that. Then again, what you do is you look at what you ended up with and you compare it to what you began with. So what are these? Are they the same, opposite, or neither? Opposite. They are opposites. So therefore, if these are opposite, it's an odd function. So what you say in your conclusion is you say that this is equal to negative f of x. That's why it's odd. See, 7 and 8 basically worked out the same way. All right. And what you would find on this is if you looked at the graph of this, it would be symmetric about the origin. So that's the idea. All right. Are you guys with me here? Okay. This is usually the hardest part of this section is getting students to write that out that way. Okay. You want to write it out technically and that way. All right. Don't just take a guess on it. Write it out like that. All right. So I'm going to do one more here. Go ahead. I want you guys to go ahead and see if you can write out number 9. Just kind of do the same thing. Give you a minute to do that and see what you come up with. Then we'll kind of get into the last part of this the next part of this section is some things that if you've had some calculus that you would have learned a little bit about. Okay, so let's kind of see how you write the proof out, and then sometimes students don't see the answer to this one quite right. So you should have had this after you replaced x with negative x, right? Because negative x to the third is just a negative number, okay? Now, if you compare these two things, if you compare this to this, are they the, whoops, hold on, what did I leave off there? Yeah, that's a 4, sorry about that. So let me do that again. Okay, so that would be 4 times negative x to the third plus 6. So that would be negative 4x to the third plus 6. Is that better? That's what you should have got. Okay. Now, are these things the same? No, because one of the terms is opposite. So it's not going to be even. They're not the same. Are they opposites? No. Okay, here's why. So if you took the original function, if you take this original function and you take its opposite, it becomes negative 4x to the third minus 6. Okay, so it's not odd either because they're not the same. So I wasn't sure if everybody would catch that or not. The idea is if you have two terms added or subtracted, everything's got to be opposite like that. Okay, so that one would just end up being neither. So that's all you got to write on your proof is that. Okay, then the rest of that is you just know that that's neither. Okay. All right, so all I'd kind of need on that is those 2 steps, and you'll be good. Okay, everybody with me there? Okay, all right, very good. Okay, so next thing I'm going to look at is we're going to kind of look at graphs a little bit. This is stuff you'll talk about extensively in a calculus class. If you took calculus before, you learned about how to use derivatives to find where functions are increasing and decreasing and stuff like that. We're not going to get real technical in this class about the definition. So the way this goes is your x values are just getting bigger from left to right for an increasing, and you're naming these on an interval. Constant just means the y values stay the same, so it's like a level part of the graph. And then decreasing would just be the y values are getting smaller, okay? You probably should read the definition I gave you outside of class and see if that makes sense to you, but you can probably get by without looking at the technicality of the definition for this class at this stage. Okay, so this is kind of what things look like. This would be a function that's increasing, and what we would say on this is increasing from 0 to infinity, and this one would be decreasing from 0 to infinity, and then this one would be constant from 0 to infinity like that. Now, textbooks are different, and this is a little bit different textbook than I've used in the past. I usually tell students, because this is the way that most textbooks define this, is with open intervals. So if you find an interval where you're increasing and decreasing, you want to use parentheses on that. I need to double check, though, on your homework and everything, because every now and then I see textbooks that'll have a bracket because of the way they have defined that. Okay, we're going to kind of follow what the textbook goes through like that. Okay, so these things right here, it's just a matter of writing the intervals, and this is going to be pretty simple, I think. So let's see, increases, I'm just going to kind of highlight that, okay, like that. Without knowing the definition, that's generally pretty easy for students to know. The y values are getting bigger. Now, what you always do is you name these intervals. You name these intervals with x values. Okay, so that's another thing sometimes I see students do wrong. So from this x to this x like this. So this x value here looks like this would be about -3. It's kind of almost looks like -2.5. I'm going to go with -2.5. And then that x value is 0. So for increasing, we would use open interval. So we'd say -2.5 to 0 as your first like that. Okay, but look at the x values. You look at the next one, this looks like that x is 2.5, and that's going to 5. Okay, so you would say union, open interval, 2.5 to 5, like that. Okay, so increasing just means you're going up the roller coaster, uphill. That's good enough for the purposes of this class so far. Okay, then decreasing would be the graph is going downward from left to right. So you're going like that, and that would be the two places where you are decreasing. Okay, so this x value is -5. So from -5 to -2.5, function would be decreasing, and then this would be 0 to 2.5 like that. Okay, now what did constant mean? That just means it was flat. Okay, so this one is never constant. Right, so use x values and open intervals to name those things. Okay, that's the thing that you want to make sure that you pay attention to. Okay. Okay, go ahead and do this next one here. Now add this too on here. So this is supposed to have a arrow saying that it's going on forever. So see if you can name those intervals on that. And always use open intervals when you do that. So this one is going to have one of each. It's going to be increasing on an interval, decreasing, and it's going to be constant. There's two places I see where it's constant, but just want to make sure you can write your intervals out okay. Okay, so what did you put for increasing? Where to where? -2 to 0, right, x values. So -2 to 0, that part that I've got highlighted in yellow. Again, open intervals, use parentheses, okay? How about decreasing? What did you put? 2 to infinity, okay, so it starts at 2, then goes on forever. So that would be 2 comma infinity like that. Okay, it's constant two places, so that would just be where it's level. So the answer you should have on that is this part right here is -infinity to -2. And then this part right here is going from 0 to 2 like that. Okay, so that's how you name the intervals. Always use parentheses when you're asked the question of increasing, decreasing, and constant. Okay, all right, everybody solid with that? Okay. Generally, I don't see too much trouble with that. Okay, on the next page, we're going to look at what we mean by maximums and minimums without getting too technical on this. The idea on this, one thing that you learn in a calculus class is what a maximum is, and this is a good thing to write down. The thing is, a maximum, a local maximum, what you're going to have on that is the graph increases, then it decreases, like that. So you just look like that. Students usually, there's a few picky details of this you got to pay attention to. So you find places on the graph where it increases and then decreases. It hits a high point. And then a local min, and I'm just going to define it this way, is the opposite thing. So the function's going to decrease, then it's going to start increasing, therefore it hits kind of a low point like that. So we call that a local maximum or a local minimum. Okay, one thing that's real important on this is you want to write this down. I don't know if I wrote this down on your notes or anything, but if you have an end point, I would write this down because you want to make sure that you understand this. An end point is not a local max or min. Okay, so if you're at the very end point of a graph, we don't consider that to be a local min or max. All that means is, the reason for that is, if it's a local min, you have to have something going on both sides of that minimum. Okay, and if you have an endpoint, you don't have that. So that's a little picky detail that you want to be sure that you pay attention to. Okay, so our textbook uses local max. Sometimes you'll see global just or absolute. Our textbook probably uses absolute, but they both mean the same thing. So an absolute max just means that's the highest point that the graph ever achieves. Okay, and you probably want to write this down too. So an absolute max or min can be an endpoint. Okay, so your highest point on the graph or the lowest point on the graph can occur at an endpoint like that. So those are the picky details you want to make sure that you don't slip up on. Okay, so local just means somewhere on the graph changes direction. Okay, something's going on to the left and right side of that then. Okay. All right, any questions about what I mean with that? Okay. Generally, now this depends on textbooks. Usually a lot of times you use the y value to name that, or you can use a point, but generally a lot of times textbooks use y values on that then. Okay. Okay, so let's just identify some of these on the graphs. Okay, how many local minimums does number 14 have? Has 2. Okay, so what I'm going to do on this is I'm just going to use points on this. When you do your homework, they'll kind of direct you whether to use a y value or a point on that. So your local minimums are going to be at -2, 0, and 2, 0 like that. Okay. How many local maximums does it have? It just has 1. So it has 1 high point in there. So that point is going to be the point 0, 1 like that. Okay. Okay, the next problem, let's see, local minimums. Okay, it looks like this one has 2 local minimums. So just name the points on here. I think I have those written down on here. It looks like -2.5 and -3.3. And then the second point looks like that is a 5 and a -2.5 like that. Okay. Then it has 2 maximums. So the maximums would be these 2. Those are local maximums. Okay, so that would be at -8.5. And the other one, is that 2, 3.9? I think, is that what that says? I have a hard time seeing that on these sometimes. Okay, so that's all that is then. So you just name the locals that way. This one does not have an absolute max, and it doesn't have an absolute min, so you might want to write down there's no absolute max or absolute min. An absolute max or min would just be the graph reaches a high point, and since this graph goes on forever, it never has an absolute high point, and it also never has an absolute low point, so it's only going to have local maxes and mins like that. Okay? Okay, so let's see. Let me do this 16, then I'll let you just kind of do one of these. Okay, look at this one right here. Does this one have a absolute minimum? Does the graph hit an absolute low point? Yeah, what's that point? 1, 2. Okay, so that's just, you look for a point that is the absolute lowest, so that's your absolute min. Okay. Now, I think this meant to be, I think I meant to type that as absolute max. Okay. Does this graph have an absolute high point? No. How come? There's an arrow. Okay. So that thing's going on forever like that. So it does not have an absolute maximum. Okay. Now, a local min, you need to find a place where the function decreases, then increases. Now, you got to be careful about this one. That one is a local min right there because the graph decreases and increases. How about this one? The graph decreases and increases, but there's a bubble. So that is not considered a local minimum for that reason. See, the thing is, this graph never really hits that low point. There's a bubble there. So it has to be defined there. So you have to kind of pay attention to these little details right there. Since you're undefined, then that's not a minimum, okay? That's not a local minimum. So you have to kind of pay attention to the little details on that. So the only local minimum we have would be 1, 2. So that's basically, it's absolute and local. They're both the same. Okay, local maximum. Does this have a local maximum? That just means increases and then decreases. Does that happen anywhere? What's the answer to the local maximum? Sorry about that. Okay, what's the local maximum? Yeah, this point right here, and that looks like 3, 5. Okay, so that's the idea. Okay, just pay attention to whether there's an open dot or a solid dot when you do that. Okay. Okay, go ahead and do this next one yourself. I'll just give you a minute to do this one, and be careful about the open and solid dots. Then I want to show you something on the calculator here. Okay, you got to pay attention to this one. First of all, what did you get for absolute minimum? There isn't one, okay? That is not an absolute minimum. Even though that's the low point, this graph actually never hits a lowest y value because it never reaches 2. Or that y value of 2 it never reaches. It may get to 2.000 forever 1, but it never gets to 2. So there's never a definitive absolute min. Okay, this I think was supposed to be absolute max. Does this have an absolute max? No, same reason. Okay, so that's a bubble, you're not defined, so it never reaches 7. It may reach 6.9 repeating forever, but it never hits 7. That's the meaning of that. Okay, how about a local minimum? What did you get on that? There isn't one of those either. Okay, and remember endpoints, when you have an endpoint, that is never a local max or min. I said that a few minutes ago, so you don't have a local min. How about a local max? Do you have one of those? No, so you don't have any of these things. Okay, that's the problem that's probably the most picky, but that's because of the bubbles that are on those 2 points right there. So you don't have any of those. All right, is everybody with me there? Okay, all right. You just want to get in this class, look at a graph and be able to identify. When you get to calculus, you'll learn how to use calculus methods to find all this. Okay, all right. If you brought your calculator, get your calculator out. It depends on you as a student. If you've been taking stuff lately in the last 20 years, you probably have learned how to do this. If you haven't been in math in a long time, you may have never learned how to do some of this. Yes?
Is it okay if we use the expired?
Yes. Yeah, that'll be fine for this class. Okay? All right, so let's see. I'm going to show you how to do this. This could be something that you've done before or not. It just depends on you. First thing we're going to do is we're going to construct a graph of this. And what we're going to do is we're going to just figure out where the function increases and decreases based on the calculator. Okay, so I want you to learn how to do this kind of thing too. So what you'll do is you'll start by going to y equals. And then we just put this in. Just put in the function that I gave you. So I'll put in the negative and then 0.3 x to the third. So you use raised to the third power like that. Then you need to kind of get that down. Make sure if you're up in that superscript that you use that right arrow key to get down out of the exponent. So then it'd be 0.2x squared like that. And then it would be plus 4x and then minus 5. So you want to start by just getting that function in. And a lot of times what you have to do on this is you have to figure out a window. Now I'm going to take off that negative 4, 5, and I'm just going to kind of look. Hold on, that's an important part of the problem. That's the interval that we want to look at. So we're going to just look from negative 4 to 5. Okay. So let's do this on your calculator. So you have the window is where you reset the x and y. So you want to press your window button like this, and then you want to go like this. You want to put in like this. You want to put in x min. You want to put that in as negative 4. And then I've got x max. And then that x max is going to be 5 like that. Okay, and we're just going to only look at that part of the graph like that. So if you're not familiar with this, you're making x start at negative 4 and then go to 5. Okay, now you got to figure out how to get the y. Now watch this carefully. If you don't know this, you have a table of values on your graph. So right above the graph there's table. So if you go second graph, you'll see a table of values. And if you do this and scroll through this, this will help you figure out how to do your y's. So notice if we're going from, you see on my calculator, from negative 4 to 5, if you look at this, the smallest y is negative 17. The biggest y value I see is probably like 1.4, okay, like that. So for that reason, I'm going to do this like this. And you can do this however you want to, but I'm going to say y min is negative 20. That will fit all those y values. And then y max, I'm just going to say 20. I mean, it's up to you what you pick as long as everything fits there. Okay, so on my window, I'll put in the y like this. So I'll go negative 20 to 20 like that, and you can scale by whatever you want to. That just, on this, I'm going to make that go by 5s from negative 20 to 20. Okay, does that make sense to everybody what I'm doing? And how I'm figuring out y? You figure out y by looking at the table of values, and that'll help you reason out a good way to do that. Now, if you type graph on your calculator, this will end up giving you the graph that we want to look at. So you want to get that window on your calculator and get that put together, okay? So what we'll do on this then is, I want to show you, you want to find this minimum and you want to find this maximum, okay? And if you ever forget how to do this on the calculator, you can go like YouTube, you can do a search for TI, finding max and min, and it'll help you recall how to do that. So what I'm going to do on this, I've already written out what you do on your calculator, so you can refer to that. So you want to try to do this. First thing you do is you go second trace, and then we want to go down to option 3 that says minimum. You don't want to estimate this. You want to get it as exact as possible. Then you press enter, and now what it's going to ask for is a bound. So you want to move your left cursor until you get a little bit to the left of that minimum. Okay, it doesn't have to be very far to the left of it, just something like that. So that you are to the left of that minimum. Then if you press enter, depending on your calculator, like I have a line that goes through to say that's a boundary. Then I do a right bound. So now I do the right cursor key until I get to the right of it. So I go like that, and then I press enter when I do that. And then I've got 2 boundaries. Now if you press enter, when it says guess, just press enter. And then that will give you, what will happen is that's the minimum right there, okay? And I'm just going to round this off. So you want to write down that you have a minimum of about negative 1 point, let's just say negative 1.9, negative 9.8. That's approximately what that is, okay? Everybody see what I did there? Okay. How many people have done this? Lots, okay. It depends on, you know, what your background in high school was. That's the thing. But you want to get confident how to do this stuff. Now we're going to find the maximum. So you do the same thing. We start over again. So we go second trace. Now you'll have option 4, which is a maximum. Then you press enter. Okay. Then you want to get over to your maximum. So what I'm going to do is I'm going to get a left bound. Okay, kind of like this. My calculator is a little slow getting over there. So that would be like, get fairly close to it. That's a good left bound. Okay, press enter. Move to the right with your right cursor. And then there's your right bound like that. Okay? So then when it says guess, press enter. And then what will happen is it should give you the maximum. And again, I'll just round that off. So that's given about 2.3 and 1.6 like that. Okay? Now that's the idea with that. We're not going to do a sketch on this, but you want to know how to figure out max and min. All right, is everybody okay with that? Okay? All right. So what we do now is you can write down these intervals of increasing and decreasing by looking at what's on the graphing calculator. So we're starting at -4. So this would be we're decreasing from -4 and then to this point here. So that minimum right there is -1.9. Okay, like that. Okay, and let's see. Next thing here is it would also be decreasing from this point and then until you get to 5. So we would say here from 2.3 and then to 5 like that. And again, we use open intervals like that. So I'm just naming the two places where it decreases. And then increasing is going to be from this x value to this x value. So that looks like that's going to be from -1.9 to 2.3. Okay, like that. Okay? Hey, this row right here, I've been watching you. Okay, when I'm teaching, okay, if you're bored, if you already know it, that's great, but don't sit there and just whisper during the whole class, okay? If you need to do that, there's the door, okay? You're the only people doing that. This row right here. So if it continues, I'll just break you up like you would a bunch of high school students, okay? So stop, all right? Thank you. Okay, any question? Anybody have any trouble what I did on that? Okay. All right, so I'm going to do one last thing to kind of finish this up today. We're going to learn about average rate of change. And this is something that's a real big thing in a calculus class. So what average rate of change is it's really just the slope of a line. So if you have a function, you have what you call a secant line. Okay, a secant line just means you take 2 points on a graph and then you connect the dots. So for instance, if you had something like if you had a curve that looked something like this, a secant line would just be you pick 2 dots and connect the line. That's what a secant line is. When you're in calculus, you learn a lot about what a tangent line is and what a rate of change is. Okay, so the average rate of change is really just the slope of the secant line. So you got to recall how to do a slope and apply the slope formula to find an average rate of change. Okay? So get in mind that when you're doing average rate of change, you're doing a slope. Okay. So one thing that you probably want to write down over at the side here is the slope formula. And you need to know the slope formula because you'll use it all the time. So what that is we usually use m for the slope. And then what we do is we just take the y values and subtract. And then you do that over the difference between the x values like that. So that's the slope formula that you use on an average rate of change. Okay. So with this one, I'm just going to do 2 examples, and you're just basically, if you can do the slope, you'll be good. So what we're doing on this is finding the equation of the secant line that goes through these 2 points. Okay. So the first thing we want to do is we have x equals 1, because that's given in this point, x is 1. So you want to go ahead and you want to find f of 1. Okay, so when you do that, you just plug into your function. So you'll have 1 to the 3rd minus 1, so you'll get 0. Okay, so what you get is you get a point, x is 1, y is 0. If you're going to find a average rate of change, you just got to know what those 2 points are. So that's point 1, we got that. Okay. Second point, what we're going to have is x is 2. So plug in, and what you'll have is when you do f of 2, you'll have 2 to the 3rd minus 2. So that's 8 minus 2, so that's 6. Okay? So your 2 points on this are going to be 1, 0, and then 2, 6. Okay? So I got my 2 points. Everybody understand what I did there? Okay? So when you do a secant line, you're just going to be looking at the line that connects those 2 points. Okay? The other formula that you want to write down is what we call the point slope formula. And this is one that you're going to use also a little bit when you're dealing with equations of secant lines. So that is y minus y1 equals m times x minus x1, like that. Okay? And those two formulas, you have to use those in order to get this put together. All right? Okay, step one, what we're going to do is we're going to find the slope. Okay, so when you find the slope, now that you've got 2 points, you subtract the y's. Okay, so I just do 6 minus 0. And then I subtract the x's in the same order. So that's 2 minus 1. Just think of it as the distance between the y's in the numerator, distance between the x's in the denominator. So that would be 6 over 2. Therefore, that would be 3. Okay, that's what the average rate of change is that's 3. What's that? Did I do something wrong? Oh, 2 minus 1 would be what? 1. Okay, I do stuff like that sometimes. Okay, so the average rate of change would be 6. Okay. All right, thank you. So that would be 6 over 1. So that average rate of change is 6. Okay. Now, the way that you do this point slope formula is you plug in the average rate of change there. That's your slope. Then you pick a point, and it doesn't matter which point you use. I'm going to plug this in. So if I take the point 1, 0, it goes like this. The x goes there, and then the y goes there. Okay, like that. Okay, so what you end up having is you have y minus 0 equals 6 times x minus 1. So the point slope formula, you got to plug the slope in, and it doesn't matter which point you plug in because you're going to get the same answer anyway. So that would give y equals, and then when you do a distributive property, that would be 6x minus 6, like that. Okay? So that would be the solution to the problem like that. Does that look familiar? I suspect most of you have done that at some point in time in your life. You find equations of secant and tangent lines all the time in calculus, and the way you typically do that is with that formula. So you want to know what that formula is doing. Okay? All right, last thing I want to do to just finish up is we're going to do an average rate of change on this, and we're finding an average rate of change between June and September. So here's June, and here's September. So this is the month, and this is the price. Now what they're telling you in this problem is you start counting like this. They're saying that April is x equals 1. So you basically have this like here. So you would end up with a point, 1, 114, and then 6 and 111, like that. Those are your 2 points. Now, if you find the average rate of change, all you're going to do is do the point. Did I count that right? 1, 2, 3, 4, 5. Yeah, I think I'm good. Okay. So I got that. Now I'm just going to take those 2 points, and if I find the slope on this, I just end up subtracting these two. So it's up to you which order you subtract these y's in. But if you choose to subtract it this way, then you need to do the x's the same way. So that would be 6 minus 1, like that. So again, what I'm doing is I'm subtracting the y's and subtracting the x's. Yes?
What did you do 388 since you're finding the change between June and September? June would be 388.
Where are you getting the 388?
Well,
Oh, hold on. We said June to September, right? Okay, all right. Sorry about that. I'm seeing I'm almost out of time, so I'm kind of getting going fast here. Thank you. So we're going to use the point 388. Is that better? I even highlighted them. Okay. So, what you do on this is you do the average rate of change. So you could do whatever order you want to do that in. We do 111 minus 88. If I do that order, then I got to do 6 minus 3. So be sure you do them in the same order. And then you can calculate that. And we can either get a decimal or a reduced fraction on this if you want to, like that. So we have 111 minus 88, and then all over 3. So that's 23 over 3. So that's a good answer. That's the average rate of change. Okay, you can just have a fraction like that then. Okay, so what happens on this is you're just taking 2 points and you're finding the slope. So with this last part of the section, you want to be sure that you know how to do the slope and how to do the equation like that. Okay, does that look okay? Okay, all right, very good. Well, thank you for coming to class. I think the snow's about to stop anyway out there. So one thing that you